Okay. In section 5.2 is called Congruent Polygons. That's its name. We're going to start on page 240. This is not going to be a difficult section. However, remember I told you that when we were talking about algebraic properties that we could use in proofs, things like symmetric, transitive, and reflexive. I told you that transitive could be covered by substitution all the time. We would not be using symmetric because x equals 5 and 5 equals x means the same thing to me, and I'm good with it. But we would be using reflexive, which is to say something like angle A equals angle A, or segment PC equals PC. You're going, why would we ever do that? You'll see it today. Okay? You'll see its usefulness. But before we get there, I want to talk to you. This is about congruent polygons. A polygon, by the way, is a closed figure made up of straight sides. Does that mean anything to you? It means once you get done drawing it, there's an inside and an outside, and you can't get from one to the other without crossing a side or a vertex. Closed figure. And the sides of it have to be straight. Can't have any curvy boundaries. Okay? So when we talk about congruent polygons, we're talking about polygons that have the same size and shape. In a nutshell, that's what congruent means. They have the same size and shape, but they might be oriented differently. One might be twisted, one might be reflected, one might be moved away somewhere else, and one might be rotated. But they have the same shape, the same size, if they are congruent to each other. We're going to start with the simplest polygons, triangles. I'm going to show you how we deal with those. If you've got a triangle that looks like that, and another one over here somewhere, these are not quite the same orientation, but I think it's pretty easy to tell. Pretend those are congruent. They're not quite, but go with me on it. ABC, and let's say PQR. I hope it's obvious to you that angles, if these are congruent, if I say that they are congruent, that it's angle C that's the same size as angle Q, right? And A, the little guy over here, is the same size as angle R. And B is the same size as angle P. They go together. They're called, get this straight because you're going to hear it a lot. They're called corresponding parts. Not because they're corresponding as we did with these. Not because they're like that. That's a different use of the word corresponding. They're corresponding because they're the same angle in a different triangle that is congruent. So C and Q correspond. That's what we're going to call them. Okay? So to do, if two triangles are congruent, then each of their individual corresponding parts are equal. So I know that angle C is equal to angle Q. I also know that angle B is equal to angle R. And angle A is equal to angle, I guess I screwed that up, not R, P. And angle A is equal to angle R. They correspond. Smallest, middle-sized one, biggest. You can tell from the shape of it what goes with it. The sides, there are 6 parts of every triangle. The sides also correspond. Here's how the angles correspond. There's 3 of those. There will be 3 sides. Like, for example, AC is equal to what?
QR.
QR. Good. And if I put this one instead, what is PR equal to? AB. Good. And the other one, CB. CB is equal to what? PQ. These are all the corresponding parts of these congruent triangles, and the parts themselves are equal. There's 6 of them. Now, here comes the part that I'm going to hold your feet to the fire on. You got to do this right. When you name 2 triangles are congruent, I'm going to put the symbol congruent here. You can use equals. You do not have to use the congruent symbol. You can use an equal sign instead. That's fine. I don't care. But on left and right, you're going to have the name of a triangle here and the name of a triangle here. And you put a triangle symbol in front of it for the same reason we put an angle symbol in front of ABC. If you mean an angle with a vertex at B that goes from A around B to C, we put an angle symbol in front. If you mean triangle ABC, you put a triangle in front of it. Now, when you name a set of congruent triangles, you can name the first one whatever you want. I'm going to call mine ACB. You can name it whatever you want. And you can even put PQR first if you want. I don't care. But when you name the other one, you have to name them with corresponding parts in the same order. So if I chose A to go there, which I did, I'm going to choose R to go first when I name it over here. You can't just throw down 3 letters here. They've got to match. So if A went first in the naming of this, which is what happened there, then I got to go R. C was my next letter, and C goes with Q, so Q's got to go next. And my last one was B, and B goes with P, so P's got to go last. These have to line up. The cool thing about it is that you wouldn't need a picture if these lined up and you were guaranteed they lined up. Watch this now. Pay attention here. In this set right here, I could tell you without, well, let me put another one up here so you don't have to reference that picture. If I had a congruent statement that said triangle XYZ was congruent to triangle OMN, here's what I know without knowing and having any picture, nothing drawn, nothing like that at all. I can tell you this, that angle X equals angle O. See how I know? I can tell you that angle Y equals angle M and that angle Z equals angle N. I can also tell you, and this is the segments here, I can also tell you that XY is equal to OM and that YZ is equal to MN. And there's one other one, and it's the front and back. So it'll be XZ is equal to ON. You see that? You see where I'm getting those from, the patterns in the statements? This is called a congruence statement. When you make a congruent statement, make sure that things line up so that whoever's reading it can tell exactly which parts correspond without even seeing the picture. Do you understand that? Same thing is true with other polygons of more sides than just 3. The same thing is true. You name it. Oh, and one other thing about naming polygons. It doesn't apply here because it doesn't apply to triangles. But if you've got a polygon of more sides like this quadrilateral right here, and I'm calling it PQRS, I need to tell you something about naming polygons. You can go clockwise or counterclockwise. You can start wherever you want, but you cannot cross through it. You cannot call this quadrilateral SQRP. You can't do that. You can't go diagonally across it. You have to go start wherever you want, go clockwise or counterclockwise, but you got to go around the thing. It's a rule. Okay. It'll screw things up if you don't do it this way. So I could call it parallelogram, or not parallelogram, quadrilateral SRQP. I could call it PQRS. I could call it RQPS. I could call it QPSR, but I can't call it QSRP. Do you understand this? You must go around. It doesn't matter where you start. You got to go around one way or the other. Cannot go through it in order to get the next letter. If you do that, it's going to make things simpler for you, and it's also correct. You have to do that. So, look at example 2 on the top of page 241. It says in the diagram, DEFG is similar to or congruent to SPQR. So obviously we're talking about 4-sided figures. And notice that they are not oriented the same, but we can depend on the congruent statement they gave us to know which letters go with which ones, which angles go with what. You can also tell by looking at the diagram, if you're careful. One thing to note, they did not put anything in front of DEFG like we did with this triangle. That's because we don't have a symbol for just plain old quadrilateral. So if you just see 4 letters, it means it's a quadrilateral. You see 10 letters, it's a dodecagon. Anyway, so if you see 4 letters, there's nothing in front of it, it means you're talking quadrilaterals here. Now take a look at what they've got for you. In example 2a, it says find the value of x. First of all, do you all find anything at all that involves an x in it? Q. 2 things. QR involves an x, and angle Q involves an x and a y. Right? I want to do the one that involves just the x, not the y. See if I can find it. What does QR correspond to in the other diagram? GF. So that means I could write 2x minus 4 equals 12. Because if they are congruent, which is what they told us, it means the corresponding sides are the same. So I would write 2x minus 4 equals 12. You see why I'm doing that? Yeah. Okay. Solving for it there is not very hard. It turns out to be 8. But if you can write the equation, I assume you can solve it. Now, to find y, the only time I see y is in angle Q. It says 6y plus x. But we now know what x is. So it's really 6y plus 8. Because that's what we got x to be. Are you with me or not? So what does angle Q correspond to? F. Angle F, which means that 6y plus 8 equals 68. Because the angles are equal also. And you solve that and get that y is 10. Does everybody need me to put this on the board? Okay, moving on then. Example 3. This lady's painting a room orange and blue. And if you're watching this video, just keep listening to the words and I hope you have a picture in front of you. On example 3, it says you divide the wall into orange and blue sections along JK. So you guys are looking at the picture while I read this. You can see the boundary between orange and blue, and it's called JK, line JK.
Mhm.
The question asks, will the sections of the wall be the same size and shape? Explain. The only way that the orange the orange polygon that you see there that she's standing in and the blue one, the only way they can be the same is if all their parts that correspond are the same. So, can you see that angle A and angle C are the same and they belong together, they're corresponding? With the marks that we have where the ceiling meets that wall is perpendicular, and same with the floor. We can also see that B and D go together, right?
Mhm.
Because they're in the corner. They're in the corners made with the with the sides marked with a double and a single, or double and a triple mark. So we can see that B and D go together. So that's 2 sets of angles. Are 1 and 4, are they going to be equal because they go together?
Mhm.
How do you know?
Because the single.
Well,
Aren't they like alternates?
they are, but are the lines that are around them, are they parallel? We guaranteed that?
Yes.
We are because, and this is just reasoning, because floors and ceilings are typically parallel to one another. That's how we're going to assume that that's true in this room as well. So 1 and 4 are going to be equal. What about 2 and 3? They go together.
Yep.
Okay, so we got all 4 sets of angles. 2 right angle pairs in A and C and B and D, and then 2 sets of alternate interiors, 1 and 4 and 2 and 3. Right?
Mhm.
So we got all the angles. Now how about the sides? What does AD go with?
BC.
Okay, that's 1 set, and they are marked as equal. What does AJ go with?
KC.
Sorry? KC, and they're marked equal, right? That's 2 sets. That's 2 sides. How about JB? What does that go with?
DK.
DK. Oh, and they both got double marks on them. That's good. That's 3. And what's left?
AB and DC.
AB and DC are, that's a mixture of, I'm talking the 2 polygons. AB is the side on the orange one, also on the blue one. The AB and DC don't belong here. We're talking about parts, corresponding parts of the orange and blue.
AD and BC.
We already had AD and BC. Those are the left and right. So we got AB and DC, they're equal, they got the same mark. We said that AG and KC have the same mark, right? That's another pair. We have JB and DK, they are equal because they both got a double mark. But where's that 4th side?
JK.
JK? Don't they both have JK as a side?
Mhm.
And if the JK that we're talking about belongs to the orange one, and the JK that belongs to the blue one, either way, aren't they the same? JK equals J.
Mhm.
That's your reflexive, folks. When they both completely share a part, so that both of them have JK as one of their parts, even if it's not marked, you can say that they're equal, because JK certainly equals itself. And if you had to use it in a proof, it would be reflexive. So we have evidence in marks for seven of the 8 parts, and the 8th part is that reflexive side. That's your first experience with it, and we are certain that that is equal to itself, and so the orange polygon and the blue polygon are congruent because all of their corresponding parts are congruent. All 8 of them. You following me? It was just that last one was weird. Now you can see it, now you've seen it, now you can get after it, okay? Let's take a look at the monitoring progress. I really like this picture right here because this is where your reasoning is going to have to come in to see if you can get the polygons to be equal to each other. If there's enough evidence or not, you're going to have to make that decision. And here's what we've got. We're not given that these are congruent. We're trying to decide if they are. This is the diagram they have in the monitoring progress in the bottom part of the column on page 241. Try to get your eyes there. SPTQR. We have, this is parallel to this. We have this equals this. This side over here equals this one. This one equals this one. And that's all we get. In order to be sure that these two triangles, these two polygons that are formed here that meet at T, in order to prove that they are all equal, I got to get all their corresponding parts. And from the marks that are on the picture, I can tell you some of the sides are equal. I can tell you that SP is equal to QR. And that PT is equal to TR. What else?
QT and ST.
Well, yeah, I'm going to try to keep the ones from the left triangle and the right triangle in order. So let's do ST. Is that okay? Keeping all of these in this triangle? All of these in this triangle, just to stay organized. So ST equals what? TQ. But I don't know anything else. I need to get, there has to be all 6 parts are equal before I can say that the triangles are equal. Which ones would I like to be equal? I'm going to have to come up with a reason for it, but which ones, which angles? I mean, for example, if I put angle S up here, which one would I like it to be equal to? How do you know it's Q? Here's how I know, and you can use this too, and it's probably just because you can tell, but I mean, if it's not clear that this one, maybe these two look like they're the same size, here's how you know. S is made with these single and double marked sides. So the one that goes with it must be made with these single and double marked side. That's Q. So the question is, does S equal Q?
Yes.
Why?
Alternate interior.
Parallels apply. Alternate interior angles are equal. That would be along these parallels here. If you extend those a little bit, it's a little easier to see. These are the ones that are parallel, and along this transversal, S and Q are equal. What other angles would I like to go together?
R and P.
R and P? I'm going to go with P first. Angle P is equal to, the question is it equal to angle R? How come? Same thing. Along this transversal. These are alternate interiors. See them? What other angles do I need? Would I like them to be equal? Here's where you get to use your autonomy. I'd number them. Those are the 2 remaining angles, aren't they? I don't want to refer to them as 3 letters. I want to refer to them as quickly as possible. So I'm going to number my diagram. Is angle 1, those are the third angles. Does angle 1 equal angle 2?
Yes.
Why?
Vertical.
Vertical angles are equal. So you may not be told outright that they are equal. We got that these were equal and these were equal because we had the parallels, and the parallels make alternate interiors equal. This one, you can see it, you can say it, and we can see the vertical angles, and so they are equal. So we have evidence, even though they didn't tell us outright and mark the picture for us, we have evidence based on what they gave us that these 3 are also equal, therefore. And that's a symbol for therefore in math. It looks like the vertexes of an equilateral triangle. Therefore, triangle, and I'm going to name it however I want, STP, and you got to be careful now, is congruent to what? Triangle what? STP goes with,
RTQ.
is it? QTR?
Yeah.
I'll buy that one. You got to go in order, and here's how you can tell. Especially if you've marked your picture like I've been trying to get you guys to do all along. If I say STP, that went from single, triple, double. You're going to have to do the same thing. Single, triple, double. It's going to have to go in that order to get those to line up. See what I mean? Okay. This is what we were trying to conclude. This is your evidence. This was marked, so we can just write it down. This, all 3 of these we came up with for something we learned before. But we have evidence that they are equal. Since all 6 parts are equal, either by marked or because we came up with that, we have legitimate reasons. We know that the triangles are. You're going to be doing that a lot. Come up with reasons why you believe certain parts are equal. Okay, let's go with example 4. We got example 4 and example 5, and I think we'll have it. In example 4, it just says to find the measure of an angle, so it's not a proof. Find the measure of BDC. We all got to find that. Can you all find BDC? BDC. Is it obtuse or acute? Obtuse. It's a big one. And it's got these 2 overlapping triangles that came in and kind of crossed over each other. Let's see if we can figure that one out. The pretty crappy drawing, but yours can be crappy too, as long as we mark through that. Oh yeah, it comes out like this. We want to find this big old angle right there. That's the question, right there, that big band right there. That's what we're after. And this is what they've given us. A 30 and a 45 here. We also have some markings. They're telling us that angle A equals angle B, and these two little dudes down here are equal. So this has got a double band, this has got a double band, and these guys up here are equal also. And we're trying to find that big old heavy mark right there. How big is this angle? 30. How big is this angle? I'm going to put these in red so we can tell these are ones we came up with. So this one's 30, this one's 45 because of the markings that we've got there. Wait, what was that? What? What you got to do, folks, is go ahead.
So we got the two 30s where it can put together, it would be 120.
Yeah, this is 120 right here. That's correct. I'm not sure it's important, but you are correct. It is 120. What? What do you want to do?
Couldn't you say 30 plus 45 plus angle D equals 180?
Angle D. We can't call it angle D, but how about 30 plus 45 plus question mark? That would work. Because see, folks, they crammed these two things together. They took these two obtuse triangles and they shoved them together so that they shared the side. We got 1, 2, 3 extra triangles out of it. It's really hard to see. Yank them back apart. Take a look at this one right here. Wasn't this one? I'm talking this one right here. Let me see if I can outline it for you. Let me get black all over my green, but I'm talking this triangle right here. That's the one I've drawn. I pulled it out. And I've got a 30 here. See that? Got a 45 up here. And I want to know this one. There's 180 in any triangle that you can draw, even the ones you pull apart. So if I've used up 75 degrees, there's 105 left. Does that sound right? And so this missing angle right here is equal to 105. But you got to be able to pull things apart either in your mind or on your paper so you can really see what you're after. Because this is all messed up, convoluted, shoved together. You pull them apart, it's a little easier to see what's happening. Okay, example 5 is a proof. And we're going to actually do this sort of a thing right here, only we're going to do it formally with a proof. And we're going to establish that the triangles are equal to each other by establishing that all their parts are equal. So we're going to do a proof next, and then we'll be done. You're going to be able to come up with reasons why you believe things about these pictures. So here's the proof. Here's the T part of it. Diagram is going to be looking like two triangles that have a, looks like a diamond. Okay, so we're trying to prove that, and usually all the time when they were trying to prove two triangles are equal, they will have them in order for you. They won't try to sell you on something that they won't do themselves. So ACD, and then the other one is CAB, and we can be guaranteed that A and C go together, and C and A go together, and D and B go together when we go to do it if we need that information. And this is the information that we are given. AD equals CB. We're also given that DC equals BA. Also, ACD, angle ACD, ACD, ACD. I'm going to call this 1, 2, 3, and 4. And so I'm going to call that, it says angle ACD. ACD, if I follow it, is angle 1. I'm going to give it to myself that way. Angle 1 is equal to CAB. CAB is 4. CAD is angle 3.
is equal to angle ACB, angle 2. Wow, that's a lot given.
We're gonna try to prove that ACD
Equals CAB. Here's what you do, folks. This is the reason why it's so important that you mark the picture. We need to mark these things as equal. And they did for you in the book too, but you need to mark it. If they just give you a bunch of stuff in a diagram, you need to mark everything that's equal first. AD equals CB. DC equals BA. They get different marks because there's no guarantee they're all equal. Angle 1 equals angle 4. Angle 2 equals angle 3. And that is 1, 2, 3, 4 of the 6 parts. So you need to clearly identify what other parts you need to prove are equal. We got 4 of them. We need all 6 before we can say they are equal. What else do we need to say in order to get the other 2 parts? What are the parts, folks, that we got to get? We've got 4 of them. Where are the other 2 parts?
AC.
AC is the remaining side. That's true. What else? What else are we going to have to establish to say that these things are equal? What? Say it louder. Yeah. We've got this pair. We've got this pair. We need this pair. There's nothing said about this pair. We also have this pair of sides. This pair of sides, we need one other pair, and it's this one. And that's the easiest one to get. So that's what I'm going to say first. And I'm going to say AC equals AC. How do I know that AC equals AC?
That's the property.
Reflexive is the word we use. You can just write reflex if you want. Okay, we got this one. Now I've got 5. Look. 1, 2, 3 sides. 1, 2 pairs of angles. I need to get D equals B, and this is a little tougher than you think. We need to get D and B in there, first of all. So here's a trick that I'm going to show you. You can say angle 1 plus angle 3 plus angle D. D equals 180, right? You see those? 1, 3, and D?
Mhm.
How come I can say that?
Triangle.
180 triangle. Good. I can also say angle 2 plus
4.
angle 4 plus angle B equals 180. Those are, see, you can say it. If you can see it, you can say it. 180 in a triangle. And I can see it. That will allow me to mention D and B and also set up a substitution. This is 180 in a triangle. Both of them. Since I got my 2 180s there, which we've seen before, I know that angle 1 plus angle 2 plus angle D, I keep saying D and writing B, is equal to angle 2 plus angle 4. This should be about 3. 2 plus 4 plus B. That's substitution. But look what I've got up here. 1 and 4 are equal, so I can knock them off because they're equal. 3 and 2 are equal, so I can knock them off. In one fell move, I can say angle D equals angle B by subtraction. Because I subtracted 1 and 4, 1 off of the left, 4 off of the right, 3 off of the left, 2 off the right. I subtracted those guys right out of there because it says up here they're equal, leaving me with D equals B. So now I have 1, 2, 3, 4, 5, 6 pieces that are all equal. Now I'm ready to say it. Once they're all there. Triangle ACD is equal to triangle CAB. And you're wondering what this reason is. We haven't actually formalized this reason. This reason is because I guess we can say 6 corresponding parts are equal. Makes the triangles equal if you can get all 6 corresponding parts to be equal. If it's a quadrilateral, you say 8 corresponding parts are equal. If they're decagons, you will say 20 corresponding parts are equal. That won't happen to you, but that's what you would say.
That's kind of what he says too. He says all corresponding parts are congruent. I guess you could say that instead of referring to the 6. But if you say 6, it just kind of indicates to me that you probably counted them. 4 were given, 2 had to be established. 1 immediately for reflexive, the other one took a little work. Okay. Give it a shot. The assignment is number 3, 5 through 9, 12 to 14. Short assignment. 9 problems. If there are any proofs in there, you better make the room to draw. And I mean, this right here should have taken a third of your page to do this, to get a diagram big enough that you can mark things without being too crowded and to write everything you need to get approved. So make your proofs big. Use the paper.